Good morning. This is page 175, problem number 12. I'm doing it out in detail for you. Hopefully it will help you understand it. I factor the denominator, then I put a over x minus 3 and b over x minus 4. Now I'm going to multiply both sides by x minus 3 times x minus 4. They cancel, I end up with 2x plus 1. Here I'm going to end up with a times x minus 4, and the other one will be b times x minus 3. I multiply through, I get ax minus 4a plus bx minus 3b. I group them together, and then I factor out the x, so I have a plus b equals 2. The 2 comes from the coefficient of the x. And I have minus 4a minus 3b equals 1. There's no x with this, so it equals this constant here. It's a system of equations. I want to get rid of the a's, so I'm going to multiply the top expression by 4. I get 4a plus 4b equals 8. I add them together, I end up getting b equals 9. I substitute the 9 into the original equation, and I find out that a is equals negative 7. So I go back up and I take a over x minus 3, I substitute in the negative 7. I do the same with the b, put the negative 7 outside the integral sign, and the 9. I integrate it, I'm going to get negative 7 times the natural log of the absolute value of x minus 3 plus 9 natural log of x minus 4 plus c. All right, let's take a look at problem number 14 on page 175. Study the last example we did. This is a definite integral, and do the same procedure. So pause the video, give it a try, turn the video back on, and see how you do. All right, that's the next step. Now look at it, study how we got it, and proceed from there. Pause the video, see if you can complete it. All right, so you get a over y plus b over y plus 1. And multiplied through, I'm going to get a times y plus 1 plus by. All right, this gives me a to the y plus a plus by. I group the y's together. I factor them. I get a plus b equals the coefficient of y, which is 1, and a is going to equal 4. Right, I subtract them, I get b equals negative 3, a equals 4. I put I put the negative 3 here, put the 4 here, I integrate them, and the final answer should be the natural log of 27 divided by 4. All right, try problem 15. Pause the video, see how you do with it. Remember, you have to multiply a by this denominator, b by this denominator, c by this denominator. You cancel out. So go ahead and try it, see how you do with it. All right, so I multiplied through. I get a times parentheses t squared plus t minus 2, parentheses, b times t squared minus t, plus c times t squared plus 2t. So I group them together, all the t squares, all the t's, and then that a doesn't have any t with it. Factor out the t squared, then factor out the t, and I'm negative 2, so I end up with a system of 3 equations. there's a dt here, but there's a 1. So negative 2a equals 1, which means a equals negative 1/2. All right, so figure out how to find out what c and b equals. Pause the video. All right, put the negative 1/2 in for a, solve each one, you get b plus c equals 1/2, and minus b plus 2c equals 1/2. Add these two together, you get 3c equals 1, c equals 1/3, therefore b equals 1/6. So now you've got numerical values for a, b, and c. You plug them back in up here. You have negative 1/2 over t dt plus the integral of 1/6 over t plus 2 plus the integral of 1/3 over t minus 1. You do the work, you'll end up with this answer. If you had trouble doing it, if you got this one correct, congratulations, that's very good. All right, number 18, definite integral. The numerator here is larger than the denominator, so you have to divide the numerator by the denominator. Go ahead and do that, see how you do. Pause the video. All right, so when you divide that, you get x plus 2. You can integrate that. Then you have a remainder of 3x minus 2, which is 3x minus 2 over x squared minus 2x plus 1. For this portion, you have to use partial fractions. So go ahead and try to use partial fractions on this. So this is just a simple integration. Pause the video, give it a try. All right, you're going to get a over x minus 1 plus b over x minus 1 squared. When you have this configuration here, you have to use this format. So I multiplied through by x minus 1 squared, gives me a times x minus 1 plus b, which gives me x minus a plus b. All right, and a is going to be equal to the coefficient of x. There's only one a to the x, there's no b to the x. So a equals 3, then minus a plus b equals negative 2. I solve it, I get a equals 3 and b equals 1. All right, now go ahead and try to finish the problem. All right, you bring this down, and then you're going to put the 3 in for the a, so it's 3 over x minus 1 dx, plus the integral negative 1 to 0 of 1 over x minus 1 parentheses squared. For this portion, you're going to have to use substitution. U equals x minus 1, du equals dx. So go ahead and finish it, see what you get. Okay, plugged it in. This is the answer you should get. Like I said, you have to use u equals x equals negative 1. All right, now I want to talk about improper integrals, page 201. Improper integrals either converge or diverge. So if we take number 2 on page 201, the upper limit is infinity. We want to know, does this have a definite answer? In other words, does it converge? As b goes to infinity, what is the limit here? So see if you can do that. Give it a try. You recall limits. All right. So you integrate it, you'll end up with this. Want to know what happens as b goes to infinity. So the limit, the upper limit is b, the lower one is 1. So it's negative 1,000 over infinity raised to 0.001 minus negative 1,000 over 1 to 0.001. This is going to give you 0. Take a while, but it'll give you 0. This will end up equaling 1,000. So the area under this is going to be 1,000. The answer for this problem is 1,000. Now try number 4. All right, to integrate this, you're going to get negative 2 parentheses 4 minus x parentheses 1/2. Want to know what happens as b goes towards 4 from the negative side. In other words, b is going to be always less than 4. With problem number 2 that we just did, it converged. It went to a particular number. Does this converge? Does it go towards a particular value, or does it diverge? So go ahead and try to pause the video and give it a try. See how you do with it. All right, if you plug in the values, if b equals 4, you're going to get 0 here. All right, the closer you get to b, the closer this gets to 0. The square root of 0 will be 0. If you plug in 0 here, you end up with 4. Square root of 4 is 2. 2 times negative 2 is negative 4 times a negative gives you a positive 4. All right, now it's an improper integral because if you put 4 in here, you end up with 0 in the denominator, and you can't divide by 0, so it's not allowable under our system of math. Now, number 6, the integral, the lower limit is 8, the upper limit is 1. Well, this implies you've got a 0 in here. Well, you can't have a 0 in the denominator. So you break it up from negative 8 to 0, and then from 0 to 1. And then you find the limit for each one of those. So go ahead and try that. Pause the video. All right, so it's broken up from negative 8 to 0 and 0 to 1. I wonder what the limit is. B goes to 0 from the negative side. All right, so from numbers as it approaches 0, from values that are less than 0. And then I want to know what is the value when b approaches 0 from the positive side. So b is going to be greater than 0 going towards 1. All right, so integrate it and see what the limits are. Pause the video. All right, so we integrate this, we're going to get 3 over 2x to the 2/3. We want to know the limit as b goes towards 0 from the negative side. And that's going to be added to the limit as b goes to 0 from the positive side, 3 over 2x to the 2/3. Plug in the values, this will give you 0. All right, this is going to give you what number? Negative 6, right? Plus, put in the value here, it's going to give you a 1. I'm sorry, going to give you a 3 over 2. This will give you a 0. The final answer should be negative 9 over 2. What you want to do is, if you didn't get the right answer, try it over, see how you do with it. All right, here's your homework. Page 175, numbers 11 through 15, number 17, number 18, page 201, numbers 1 through 7. Have a good day.